Imagine a fighter jet so fast it could melt itself just from atmospheric friction. So high-flying, it operates on the boundary of outer space, and so heavily armed, it can destroy entire squadrons with exotic laser weapons and swarms of hypersonic missile attacks. This isn't science fiction, it's Russia's mysterious MiG-41 interceptor program. And according to the Russian defense analysts, this next-generation air power terror is already taking shape behind closed doors, pursuing performance capabilities that laugh in the face of conventional physics and engineering. Strap in and prepare for an in-depth look at the Russian aerospace gambit that has the Pentagon watching the skies with dread. But first, let's take a step back and examine the proud lineage from which this new fighter emerges. The storied Mikoyan-Gurevich Design Bureau has been building stallions of the sky for the Russian Air Forces since the 1940s. Two of their most legendary creations were the MiG-25 Foxbat and MiG-31 Foxhound interceptors. These Cold War-era workhorses were true deadly. The Foxbat could reach an astonishing Mach 3.2, while the Foxhound wasn't far behind at Mach 2.83. Over 1,100 MiG-25s were built, a staggering number that spoke to the fearsome reputation this jet had attained. The MiG-31 took the concept even further. While slightly slower than its predecessor, it more than made up for it with an arsenal of advanced missiles and the ability to launch offensive attacks from the front seat for the first time. This Foxhound was a true aerial predator, equipped with a mix of guided missiles like the semi-active radar-homing R-33 and the deadly R-37 long-range air-to-air missiles. It could even carry the massive KH-31P anti-radiation missile to destroy enemy radar sites from vast distances. Combined with low-altitude supersonic ability and superior maneuverability, the MiG-31 marked a significant leap forward and cemented Mikoyan's reputation. And this is where the MiG-41 program comes thundering into the picture, an ambitious undertaking that could potentially rewrite the laws of aeronautics as we know them. While details remain scarce, as Russian officials keep this project tightly under wraps, the few tantalizing morsels of information that have leaked out are enough to raise eyebrows across the aerospace community. The statements from Moscow indicate they intend for the MiG-41 to embody all the advantages of its legendary Foxhound predecessor, a staggering goal when you consider just how groundbreaking the MiG-31 was in its own right back in the 1970s. But if the whispered performance specs are even halfway accurate, the MiG-41 could put the previous generation's achievements to shame entirely. Rumors indicate this new fighter is being designed to strike targets at mind-boggling speeds greater than Mach 4, over 3,000 miles per hour. To put that in perspective, an aircraft like that could cross the entire continental United States, from coast to coast, in just over an hour's time. Achieving such blistering velocities would require breakthroughs in multiple cutting-edge disciplines, not least of which is materials science. At those speeds, the severe aerodynamic heating from atmosphere friction alone could theoretically cause the airframe's skin to begin melting like a shooting star, burning up on re-entry. Preventing such a catastrophic failure would necessitate incorporating new ultra-high temperature ceramics, composite materials, and thermal protection solutions on an unprecedented scale. Even the latest hypersonic vehicles, like the X-51 Wave Rider, have only had to endure such extremes for short bursts. But the MiG-41 would be asked to sustain that hostile environment indefinitely. Then, there's the issue of propulsion technology. In order to accelerate to and maintain those blistering 4,000+ mph speeds for any meaningful duration, the MiG-41 would likely need to incorporate an advanced combined cycle or turbo ramjet system. These engines are exceptionally complex, combining the efficiency of a turbine engine with the high-speed performance of a ramjet or scramjet. Very few aviation powers like the United States have even begun serious testing of these systems, which are a far cry beyond the conventional turbofans of today. Russia would be breaking significant new ground here. As if those technical hurdles were not daunting enough, the claimed performance envelope gets even more breathtaking. Russian sources have stated the MiG-41 is being designed to operate at near-space altitudes exceeding 100,000 feet, over twice as high as most modern fighters, which typically top out around 60,000 feet. Uncharted territory like that could very well necessitate incorporating elements of experimental spaceplane engineering into the airframe and flight control systems. The stresses on the airframe would be immense, entering the rarefied realm of orbital bombardment systems, and perhaps most critically of all, for an interceptor intended to engage targets in that stratospheric high ground, the MiG-41 would require sensor systems, tracking capabilities, and weaponry specially engineered to operate at those ultra-high altitudes and velocities, where even the slightest miscalculation could be catastrophic. Achieving the required degree of precision and lethality at the intersection of hypersonic and near-vacuum conditions presents an entire multivariate calculus of technical challenges that have scarcely even been theorized, let alone solved. So, while the confidence from Moscow is admirable if somewhat expected, the MiG-41 program faces a truly uphill climb towards realization, especially if their claimed timeline for testing and operational deployment is to be believed. Bringing together all the required advancements in materials, propulsion, sensors, aerodynamics, and weapon systems into a single integrated system is an enormous ask that would push the boundaries of aerospace engineering into uncharted territory. Many analysts are openly skeptical whether Russia has the resources, expertise, and industrial capacity to pull off such an ambitious and risky undertaking anytime soon. But if they do eventually succeed in taming this particular aerospace chimera, the implications for the future of air superiority could be seismic indeed. But arguably, the most frightening aspect of the MiG-41 program is the proposed weapon suite intended to arm this new fighter. From what little information has been divulged, it seems the Russian engineers are aiming to create a veritable flying arsenal capable of projecting overwhelming multi-domain firepower at extreme ranges. We know the MiG-41 is being designed to carry a vast array of armaments, likely incorporating cutting-edge hypersonic missiles and even directed energy weapons like air-to-air lasers. An unprecedented concentration of devastating lethality for an aircraft its size. Central to this formidable missile truck concept is the idea of a saturation attack capability, made possible through an innovative weapons disbursement system. Reports indicate the MiG-41 may use a missile dispenser of some sort, an underwing launcher that can ripple-fire multiple individual submunition missiles in a single salvo to swarm and overwhelm enemy targets from various attack vectors simultaneously. It remains unclear if these would be miniaturized munitions optimized for swarming, or if the dispenser could actually handle full-size air-to-air missiles. But either option could present a legitimate operational nightmare for adversary air defenses. The other particularly alarming aspect is the proliferation of anti-satellite strike capabilities reportedly being incorporated into the MiG-41's design. Not only would it allegedly carry conventional longer-range air-to-air missiles capable of targeting space-based assets in low orbits, but Russian media has broadcast claims that some versions may even feature powerful laser weapons specifically designed to dazzle, disable, or destroy enemy satellites outright. If genuine, this could grant the MiG-41 an unprecedented anti-satellite capacity far exceeding anything currently fielded. Taken together, this implied array of next-generation ordnance points to a fighter that could potentially degrade an opposing force's capabilities at every level: air, ground, and even exo-atmospheric. Whether it's swarming hypersonic SAMs, blasting enemy fighters with focused energy beams, raining destruction on ground forces with precision strikes, or simply obliterating entire space-based reconnaissance and communication constellations with co-orbital munitions, the MiG-41 seems purposely designed to establish complete battlespace dominance in the most unforgiving way possible. Of course, arming such an advanced munition suite raises a host of technical challenges itself, beyond simply bolting on bigger rockets and lasers. Sophisticated sensor fusion, advanced fire control systems, and highly secure digital networked communications would all be required to prosecute coordinated, precise, and sustained attacks against diverse and scattered targets. Electronic warfare and defensive countermeasure suites would have to incorporate never-before-seen capabilities to thwart incoming hypersonic threats or orbital beam missile strikes. And then there are the stealth considerations. Much of the MiG-41's power could be negated if the aircraft fails to incorporate robust, low-observable characteristics and counter-radar technologies from every angle, including the top-down bell-ringer threat posed by hostile satellites themselves. Without a comprehensive multispectral stealth design hardened against every detection modality, the MiG-41 could potentially be exposed and tracked so thoroughly that it can never even get within striking range of its targets. So, while the promised degree of multi-role lethality is certainly enough to induce nightmares in the corridors of the Pentagon and other Western military commands, the MiG-41 weapons architecture raises just as many questions as it portends potential threats. Much will depend on just how seamlessly and effectively the Russian aerospace designers can integrate all these diverse subsystems and capabilities into a single coherent airframe that doesn't sacrifice too much in terms of raw cost, weight, and maintaining sufficient performance margins. It's a tremendously complex juggling act, and the fact that we've seen so little in the way of actual component prototypes or solidifying requirements from official Russian sources only breeds further uncertainty about what realities may manifest when the MiG-41 potentially takes to the skies. For now, the public can only speculate as to what hellstorm of destruction this enigmatic aircraft might be capable of unleashing. When the MiG-41 program was first unveiled to the public, Russian officials projected an extremely aggressive development timeline that stunned aerospace analysts worldwide. According to the initial statements from the Mikoyan Corporation itself, the plan was to have a fully functional technology demonstrator prototype completed and ready for first flight testing by as early as 2023, just a couple years away at the time. If that ambitious milestone was achieved, the schedule then called for beginning official flight tests of the MiG-41 in 2025. Followed by declaring full operational capability and entering service with the Russian aerospace forces by 2028. Such a blistering fast pace would be unheard of for introducing a radically new aircraft design into operational service, let alone one making the incredible performance leaps promised for the MiG-41, like hypersonic velocities over Mach 4 and near-space operation above 100,000 feet. By compressing testing, evaluation, and transition to a combat-ready state into essentially a 5-year window, from 2023 to 2028, the Russian program would be accomplishing in a fraction of the time what typically takes other major aviation powers like the United States a decade or more to achieve, even for relatively incremental upgrades to existing designs. Not surprisingly then, the vast majority of professional analysts and subject matter experts have openly scoffed at the credibility of such an unrealistic, overly optimistic timeline for the MiG-41 program. The technical difficulties and steep developmental hurdles still to be overcome with this aircraft are simply too monumental to plausibly expect the first production examples to start rolling off assembly lines before the 2030s at the absolute earliest. And that's assuming every aspect from advanced materials to revolutionary propulsion to sensor integration comes together flawlessly on the first attempt. Given the incredible complexity of merging all the required next-generation technologies like hypersonics, material science, stealth, electronic warfare, and terminal weapon effects into a single airframe design, most reputable forecasts see the MiG-41 facing delays that could push its entry into service back another 10-15 years from that 2028 projection, if it gets there at all. Betting on such a high-risk, cutting-edge development program being able to sidestep the typical growing pains, setbacks, and incremental rework that even the most mature aerospace efforts almost inevitably encounter seems extremely unrealistic, barring some sort of genuine engineering miracle in Moscow. And that's not even considering the macroeconomic and geopolitical challenges facing Russia that could present further barriers to success. The country's financial resources and productive industrial capacity have already been significantly strained by the impacts of economic sanctions and trade restrictions due to its conflict with Ukraine. Other major Russian defense aviation projects like the Sukhoi Su-57 stealth fighter program have lagged in development for over 15 years now, due to bottlenecks in funding, supply chain issues for critical components, and difficulties with incorporating modern sensor and networking suites. With the MiG-41's unprecedented ambitions reaching so far beyond the already struggling Su-57's troubled path, the program seems positioned for an inevitable reckoning with fiscal limitations and capability shortfalls in its current form. Unless Moscow can find major new infusions of capital, technical expertise, and manufacturing resources from either domestic or foreign sources, Russia simply may not possess the manpower, facilities, and economic capacity to realize the MiG-41 under its current funding model and schedule constraints. Only time will truly tell whether the MiG-41 emerges from the shrouds of secrecy around Russia's aerospace laboratories and testing ranges as a genuine next-generation threat, or if it proves to be merely the latest in a long line of ambitions that far outstripped eventual realities. But one thing is for certain, every military intelligence agency in NATO and throughout the Western defense sphere will be watching Russia's every move with keen interest, braced to analyze the inevitable setbacks or unexpected technological leaps as this high-stakes gambit unfolds in the years ahead. The implications of success could massively disrupt the current world order, but failure seems the more likely scenario for now. It's a cliffhanger that has serious consequences for the global balance of air power supremacy either way. So there you have it. The full story on Russia's quest to field the unprecedented MiG-41 interceptor that has military planners throughout NATO and the West watching with trepidation. Let me know your thoughts on the MiG-41 situation down in the comments. What are your predictions for how this next chapter in the continuing struggle for air mastery will play out? And don't forget to subscribe to our channel and click that bell icon to stay up to date on all the latest revelations in the fascinating world of military aviation.